Welcome to episode number 30 of Profit or Loss, the series where I buy a bunch of broken stuff from eBay, try and fix it and sell it for a profit. In recent weeks, Sally's spectacular spreadsheet is not looking good. Hopefully with today's items, we can bump it up a little bit and get back on a winning track. Enough jibber jabber, let's take a look at item number 1. An Xbox One S console that I paid a total of £30 for. I've not worked on an Xbox One S for a while, so I'm actually quite excited. However, looking at the eBay listing and the type of fault that it is, maybe I shouldn't be so excited. The listing actually states that you can only turn the console on by pushing the eject button, but after you've pushed the eject button, it beeps to signify it's turned on, but then nothing happens and it just dies. And to be honest with you, the power button feels really spongy, almost like it's not clicking. So I don't know if that is going to be at fault to start with. I think our best bet is to take it apart and just have a look and see what's going on. The warranty sticker has been taken off before, and you can see that there is a little bit of damage to the actual chassis itself. We have quite a big mark on the top as well, but other than that, it's not in bad condition. It doesn't actually look like the front of the console is in properly, but I could be wrong. So I'm going to continue taking it out. I mean, that would actually make sense. The button itself is gone to turn the machine on. I should have a few replacement boards actually. Unplug that board and put our test board in, which, as you can see, has the button here. Right, what happens when we go to plug it in? Give it some power. 3, 2, 1. Okay, so we get a beep. I don't know if that's coming across in the mic or not. So we definitely get a beep, but nothing happens at all. So it's not even beep on, beep off. It's just beep, nothing. Okay, interesting. Let's continue taking the rest of it apart. Let's quickly make sure that this power supply is okay. Now, we're getting the initial beep, so I don't want to just test for 12 volts. I'm just going to get a replacement power supply and try that in the console instead and see if we get any different behavior. Before I do that, I will just check that I don't have a 12 volt short on the board. Meter in continuity mode, mode that beeps when we put the probes together. Do we have a short? Negative, positive, no beep. So we don't have a short there. So let's just test another power supply. Plug this one in. Do we have any difference now when we go to press the power button? We get a beep. Nothing. Still beep and does nothing. Okay, so we can rule out the power supply being bad. As I said, it's been a hot minute since I've actually worked on one of these, but this board is in extremely good condition. I can't see anything that jumps out at me that might indicate we have an issue with the power. Let's head on over to the microscope and see if I can see anything else close up. This down here on the right side of the board is the 12 volt power rail, but again, I don't think our issue will be around here, to be honest with you. It very well could be, but I highly doubt it. This was an area of concern for me, but this I'm pretty sure is the RAM controller IC, and in my experience it's caused a lot of beep on, beep off, but again, we're not getting the beep off situation. It's almost like the console just isn't starting up to begin with. Don't think it's going to be that. Another random little guess would be this chip here, which is the NCP4205. It's a power management IC for the Xbox, so maybe this has gone bad. It's not completing that startup. And we also have our usual culprits of like the retimer IC, which might be causing it to not power on if it's shorted. But I think first things first, we're just going to make sure that we have all the voltage rails. So the 1.1, the 1.8, 3.3 and the 5 volt. Because we know we've got the 12. The 12 is okay. Multimeter in continuity mode without actually applying any power. We're just going to see if any of those lines are shorted. 1.1, do we have a short? No, we don't. 1.1 is fine. 1.8, no short on 1.8 either. 5 volt, no short on 5 volt. 3.3 as well here. Doesn't look like it. No, all our lines seem to be okay. I'm just going to check over them with the power on now. Just in standby mode. Power's going into the board now. I'm going to read out to you what I have. So I have 3.3 on the 3.3. Do we have 5? Yeah, we have 5. Do we have 1.8 and 1.1? 1.8, yep, and 1.1. Yeah, so all our voltage rails are present. I will, for the sake of it as well, just make sure that we have 12 volts coming in, because even though we didn't have a short, I haven't tested to see if we do have 12 volts. Pretty sure it's this side of the cap. Yeah, it is. Yeah, 12 volts. So we have 12 volts coming in. Okay. That MOSFET there, though, doesn't look... Oh, no, they're all like that, to be fair. I was going to say, the solder doesn't look great. Just to see where we have, like... I'm talking about here. From this angle, it looked like it was non-existent. But when you tilt the board up, there is solder there. I'm just going to start prodding around the board to see if I can find any sort of short or anything along those lines. Alright, so we're over with our thermal cam, and as you can see, the only thing that seems to be getting hot is the APU, and it's quite a hot temperature. It was pushing, I think it was 50 degrees. So what I've been doing is just injecting power on the 12 volt line to see if anything abnormally heats up. So if I do that now, you'll see I'm injecting now. So it tops out at 1.5 amps and then just constantly restarts. And as you can see, the CPU is getting extremely hot. Nothing else on the board. If I zoom out a little bit, you've got South Bridge, but I think, to be honest with you, I think the South Bridge is okay. Feel free to tell me different if it's not, but I know that that kind of ramps up in temperature anyway, trying to turn the console on. But as you can see, look, we're pushing 50, nearly 50 degrees Celsius on one part of the on the APU. Not all of the RAM chips light up, so we've got like 4 RAM chips up here that don't light up, plus this one on the left. I'll show you again. You see the small heat spots now. So not all of the RAM gets hot. So I don't know whether this is RAM or whether it's APU, but I think it's APU. I'll just get rid of this thermal paste, etc. that's on the actual APU itself and see if I can see any cracks in the die or anything along those lines. Okay, let's look closely. Majority of the heat was coming from this side here. Doesn't look like we have any cracks on the actual die. I've just checked over the CPU. I can't see any cracks or anything in the die. Make sure I give it a good clean. It looks okay. It may well be the RAM that we have, but we have about 4 or 5 sticks that don't seem to be getting hot, all in different places, but I also don't know if they're all meant to switch on at the same time. And I have ordered a stencil to be able to reball the RAM. I've got it from AliExpress, so it's not going to be here by the time I publish this video. I did look on eBay, but there's none for sale on eBay. So what I'm thinking is if we actually save this board for a live stream. So we're going to park it for the time being. I do think it's going to be either the RAM or the APU. 70% sure it's APU at this point, but it will make for good content on a live stream. That means we are currently down £30 at the moment. It was actually a 1 terabyte drive, so even if we can't get it working, we should be able to recoup some money here. Now, let's move on to item number 2. Believe it or not, I only actually paid £30 for this Nintendo Switch Lite. Let's just pause the frame right here. I actually paid £40 for this console. Somebody has been in it to fix it before. So again, today is not looking fantastic. Apparently, the charging port has been replaced once already, and the Switch has no power. The charging port itself in here now looks okay, but we don't know if it's properly soldered to the board, and we don't know the history of the device. So I'm going to get this open now, down to the board, and we're going to see if hopefully we can fix it. Whilst I'm taking this apart, I feel like there might be a few people out there that think I may have rushed the diagnostic process on the Xbox One S to come to the conclusion that it was going to be either RAM or the CPU, which I actually completely understand, because in a way I feel like that as well. But I feel like when repairing electronic devices in this line of work, a lot like any other line of work, I guess, with more experience comes being able to diagnose things quicker. I did spend a while measuring caps on the board to see if there was any shorts or anything along those lines, but I couldn't see anything. So what looks like to you will be 30 seconds to a minute worth of footage is sometimes 30 minutes of me actually going around the board and checking to see if I can find anything. In this occasion though, it didn't take me that long to come to the conclusion that it's either going to be the APU or the RAM. And I guess with the series that I'm doing currently, which is trying to make a profit, ideally we want to try and reduce our labor time as much as possible, which I guess it isn't factored in the spreadsheet, but that's why we give a gross profit rather than like a net profit. I was thinking perhaps maybe I could reflow the RAM and see if that makes a difference, but that almost feels like half a job to me, so I might as well wait until I actually get the stencil itself. Right, out comes the board. Let's get it over to the microscope and see what the situation is. Now, what you will notice as well is I didn't use our trusty little ammeter to see exactly what was going on. And the reason being is because I didn't want to make this any worse than what it is, because it's already had work done to it before. So I don't need to kind of know what the fault is with the console. I can clearly see from this that I know what's wrong. Let's just check the back to ensure that the back was done okay. There's a lot of flux residue around here. Makes it very, very sticky. So you can see it's still just not, it's just so much flux. Again, as confirmed by a lot of people, it doesn't harm the board. It's just not nice. Because it's still sticky, I might just be able to come in with some IPA and get this off the board now, just to give us a little bit of a better idea as to what's going on. I don't know what kind of flux the customers used, but if it stayed like quite liquidy after all this time, that's saying something. Basic checks might be needed. There is a tiny solder ball there actually. There's one here, which just needs to go away. And then we've also got one here. Yeah, grab a toothbrush and make sure there's no other little loose balls. The plastic has been singed quite badly on the port. Again, I think the port itself is okay. I'm now just weighing up in my head whether I'm going to feel comfortable leaving this port on, because other than the burnt plastic and the pins, some of the plastic has gone down to the pins, but I don't know what the line of pins will look like underneath here, so that's what I also need to be cautious about. But the port doesn't look too bad to reuse, if I'm being honest. Even the back isn't, I mean this bit isn't cinched here. It might just need a reflow, but then again I'm thinking with my own port, I know it would be a good job. Let's take this one off. I'm going to put mine on. This is already going to have leaded solder, so I shouldn't have to use too much heat. Let's get this put. It smells horrific. Do you know what it smells? It smells like petrol. That is not good. Horrible smell. You actually need to put the extractor on for this, you know. Just taking the port off. Solder's starting to liquefy, as you can see. Just going to wait to make sure. I'm going to give it a bit of a poke. There we go. So that should be okay now. Yeah. How are we looking pads wise? Pads wise looking alright. Sorry about the shakiness. Just have to have the fan on. I am, for a change, going to see if I can get the solder out because it's leaded. Instead of using the solder sucker. Solder sucker would be a lot quicker, but for the sake of science. I know I've just spoken about trying to get labour time down as well. This one should be fine. These usually come out pretty much straight away. Yeah. It's the back ones. They're a little bit tougher. Just know with that with the copper braid. It's fine. It's okay. The battery compartment. That might have to be... Yeah, it looks like I'm going to have to solder sucker those out. I don't know how sensitive these pads are going to be, so I'm going to have to be careful. Not looking great right now, are we? Magic of isopropyl alcohol and a cotton swab. We're going to look good. Clear out those ground holes quick. How does that look? Yeah, nice. Lots better. Might just have some flux. Yeah. We're looking okay though. Fill up everything with flux. Take our solder. Nice leaded solder. And tin everything. Nice. Good. Straight away with the cotton swab. Get all that flux off. So we don't need that much flux. Nowhere near. Just make things messy and sticky. And now we're going to look at putting a port on. Make sure we tin that port. It's a little bit of like stuff that was on my eye in there. Might need to get down to just those ones. There we go. Nice. Tiny bit of flux. Because we're going to have some on the port as well. Where we've just tinned it. I've got an Atten ST862D hot air station. And temps I'm currently using is 440 degrees Celsius with an airflow speed of 25%. Patience is key. Drop the port on. Keep rotating. The port's not sat down as you can see, so we're just going to give it a couple of seconds. With that heat. A little bit of a nudge. There we go. Need to make sure we can see enough of those pins at the back. So I'm now just pushing down. Maybe come out a little bit. There we go. Pushing down, holding with the heat as well. Making sure we get a good connection here. Making sure that heat has been held on for long enough for the port itself to bond with the board, which I think it has. So come off in 3, 2, 1. Off the heat. Let that solidify. Usually I look at the ground legs. There we go. There's one. Now we get a bit closer. Inspect the pins. They look good. I'm just going to go over them with the iron. A little bit more flux. And then we'll give it a nice clean up. A bit shaky. Tiny bit of solder on the end of the iron. I'm just going to simply touch that. Might have a few bridges, but we'll deal with them. Again, trying to find the right iron tip for this on my Hakko. This is quite a big one. Just moving that solder over. Might be a tiny bridge over here as well. 2 and 3. That's gone. That one might be gone as well. Maybe. Right, let's give it a quick clean. To be fair, that tip might have done an alright job, you know. The back looks nice. Looks really, really nice. I've not gone over these at all with the soldering iron, and to be honest, they look really, really good. Strong, secure, really nice. I've been a bit of a moron as well. I didn't test M92 T36 see if we had any shorts whilst the port was off the board, but regardless, that port needed to come off and get changed anyway, so I'm not too bummed out about it. How is our port looking? Any bridges? No, that looks really good. And you can see that the solder is wrapped around all of the pins nicely. Good strong connection, no burnt plastic, except for maybe underneath the port. I'm just going to check quickly. We can stop the wobbling now as well. Let's check. Good. Every single one is solid. I do need to run the multimeter over the fuse to ensure that we have continuity on it. And I'll just check M92 T36 very quickly as well. So fuse, meter in continuity mode. We have continuity perfect. M92 T36, do we have any shorts around the area? No shorts. What about BQ? Oh, what's that? Oh, I thought there was a hole in the chip then. Okay. Let's just check anyway. All good as well. Okay, so testing with the ammeter. What actually happens when we plug it in? Do we get anything? We get something on the screen, 0.01. Does it drop down? 0.2. Doesn't drop down to 0, which I think is normal behavior. It should drop down to 0. Don't know why it's not. Let's try the other side. 0.02, 0.04, 0.00. That is what we want to see. That behavior was a lot better. Let's try this side again. 0.02, 0.04, 0.00. Okay, maybe it was just having a funny couple of minutes. That should be a working port. We do actually need to Dremel the port. I'll do that off camera so I don't bore you, but I need to Dremel it so it is in line with the actual PCB itself. Don't know if this is maybe like a millimeter that I need to shave off, but what I'd like to do is actually put it in the housing first to test and make sure the screen works, etc. But that is a good job so far. I think I've got it back together enough to test. I need to replace this analog stick. Again, there's not really much point in me showing you that. So let's see if this powers on. Come on. I just want to at least see something on the screen if we can. 0.07, which is good. There we go. Okay, so we have the charging symbol. It's 100 milliamps at the moment. That's probably because the battery is ridiculously dead. Ideally, before I change out the thumbsticks, what I want to happen is to get to the main menu screen just to make sure we're all good. Okay, it's gone up to 50 milliamps. I stepped away for a little bit, so I didn't see if it actually turned on or not. So let's see if it's on. Yes, it is. There we go. Okay. Touch works. Touch works fine. We don't have parental controls, which is really, really good as well. There's one thing I want to test before I get too excited. Okay, good. The screen is fine. Okay, I'll Dremel the port, change out the thumbstick, make sure it plays games, etc. Then we can head on over to Sally's spectacular spreadsheet to see if we made a profit or a loss. I think it's going to be close this week. Here we have it. The switch has been put back together. I've given it a decent clean. Some of my just smudge marks where I have my gloves on. It works fully. I've tested game cartridge, Wi-Fi, all aspects of it. That's the port. It lines up nicely with the actual case itself after I've Dremeled it, so all good. I paid £40 for the Nintendo Switch Lite and £30 for the Xbox One S, so £70 for both of them was our cost. Parts wise, we were only able to fix the Switch Lite, so that's going to be £1 for the USB-C charging port. I wasn't able to fix the Xbox One S, unfortunately, but I think we should be able to get in this condition around £90 to £100 on the Nintendo Switch Lite, so I'll put £100 in sell price, not £1,900, I wish. And today, we actually have a gross profit of £22 and 10 pence. Let's add that to the total spreadsheet, so £22 10 pence. The total profit we're looking at is £397 and 82p. When that stencil comes, I'll look to do a live stream so we can revisit that Xbox. Watch here for the latest episode in the series, or here if you want to watch the playlist and start from the very beginning. And here to subscribe. Thanks for watching. I'll see you in the next one. Peace.